Hello, everybody. I'm Yuni WULANSARI from STIS Polytechnic of Statistics and BPS Statistics Indonesia, Jakarta. I like to share our research on estimating the disaggregated regional official statistics in Indonesia using EBLUP benchmark small area estimation methods, uh, and we are using R, especially in the calculation of school participation rates for university as STIS indicators. Well, the background of this study about the EBLUP method is a popular method in small area estimation, but the aggregation of the estimated value cannot guarantee consistency with the estimated value at the domain level above it. The direct estimation of official statistics is estimated according to the survey design. Generally, the sample is not sufficient for national or provincial level estimates, so that small area estimation is made for district estimation level. And official statistics require the consistency of the aggregate estimates with a higher level of domain, whether national or provincial level, and benchmark small area estimation method is developed to obtain consistent estimation results with a higher area level. This is about the SI benchmark concept. Suppose that theta I is the ith area mean, and theta plus is the aggregate mean, and WL is the known proportion of units in area L, and all areas are sampled. Assuming that the direct estimator of theta plus is reliable, it's desirable to ensure that the estimators of small area means, when aggregated, agree with the reliable direct estimator. The EBLUP estimators do not satisfy this benchmarking property, as we can see here. Therefore necessary to modify the EBLUP estimators to ensure benchmarking. These are benchmark methods stated by Rao and Molina. First is ratio benchmark, and then different benchmark, optimal benchmark, and self-benchmark consists of Euro benchmark and augmented benchmark. First, ratio benchmark or RB. Ratio benchmark is one of the most widely used methods of modifying EBLUP estimators. It consists of multiplying each estimator by the common adjustment factor, leading to the ratio benchmark estimator. So that will be obtain the benchmarking property. However, ratio benchmark has the limitation. A common adjustment factor is applied to all estimators regardless of their precision, and then the estimator is not design consistent, and the second order unbiased MSE estimators are not readily available. The other method is different benchmark or DB. Basically, it's similar to the benchmark ratio, except that the correction factor is carried out by taking into account the difference between the estimation results of the direct estimator and the estimator of the EBLUP. Suppose that the DB estimator is a modification of fair Harriet estimation by adding it to a constant alpha. So the DB estimation consistent when aggregated. So the estimator meet the benchmarking properties. Similar to the benchmark ratio, this method also has limitation. It uses the same multiplier for all estimators. It's not design consistent estimator. Although the MSE of this method can be obtained unbiasedly according to Sturt and Ghost 2013, MSE different benchmark can be greater than MSE of EBLUP. We can see here. And another method is optimal benchmark or OB. Pfefferman and Bernard so that it's impossible to find a best estimator of theta I for each area I in the class of linear estimators T that are model unbiased and satisfy the benchmarking property. For each estimator T, which is linear, unbiased, and meets the benchmarking requirements, Wang, Fuller, and Ku found T that minimize the function for specified positive weight. And these are the optimal benchmark estimators. So the benchmark estimators satisfy the benchmarking property. Optimal benchmark can solve the limitation of the benchmark ratio method and different benchmark. However, the optimal benchmark method has not been able to formulate its MSE estimator. The another method is Euro benchmark or YR. The self-benchmarking method doesn't have the deficiencies that occur in the benchmark ratio. In this method, the adjustment is not made with multiplying factor in EBLUP estimators, but by modifying beta hat on EBLUP variate by including a weighting component. The MSE can be calculated. And this is the Euro estimators. So the estimator meets the benchmarking properties. And this is the MSE computation of Euro benchmark. And the last is augmented benchmark or AB. The augmented benchmark method is one of the types of self-benchmarking developed by Wang, Fuller, and Ku. This method is done by adding predictor variables, HI, in the Fay-Harriet model. The EBLUP under the augmented model is denoted as eta hat I. And this estimator satisfies the benchmark constraint. With the assumption of normality and the use of restricted maximum likelihood to estimate variance random effects, MSE eta hat calculated in the same way as calculating the MSE of EBLUP estimator. And we employ the small area estimation benchmark using R. We use the three methods, namely different benchmark, Euro benchmark, and augmented benchmark. We didn't use the optimal benchmark because we still cannot count and measure the MSA. The first step, we input the data and then we check the dimension of the data. We can see here that in this preliminary research, we use one dependent variables, one response variables, and two predictor variables. When we check the relative standard error of direct estimator, we found that there are several districts that still have the relative standard error above 25%. So it clearly needs the small area estimation. This is our direct estimates variables. We use school participation rate, university as response variables. We employ the small area estimation methods for district level or cities level in Central Java. And the data sources from Susanas and Bodes. In general, the use of EBLUP benchmark function is similar to the EBLUP function in the ASIE package. But in the benchmark function, we add weight as additional input. Weight is is a weight which when added up is 1. The aggregated direct estimates are 20.00091. So the aggregation of EBLUP benchmark estimates is expected to be close to or equal to the aggregation results at the provincial level. Then we run the R script, which is function psi benchmark. First, we are fitting EBLUP model different benchmark. The function name for different benchmarking is EBLUP-DB as follows. And we obtain the EBLUP-DB estimators, as we can see here. Then we check the aggregation results. These are the estimation for each district. And then when we aggregate it to the provincial level, we can see that when using EBLUP different benchmark, the aggregation result is consistent. And then we also check the MSE and RSE of different benchmark estimation. We conclude that the different benchmark method can improve the estimation because we can see here that the RSE or relative standard error of different benchmarks is lower than direct estimation. So the precision of the estimation is increased. And then we are fitting EBLUP model using Euro benchmark. The function name of Euro benchmarking is EBLUP YR as follows. The estimation results of EBLUP Euro are stored in S_YR to display the 5 results of the EBLUP Euro estimation, as we can see here. And when we aggregate it into provincial level, we meet the consistent estimator. We also check the MSE and RSE also, and the Euro benchmark estimation improves the precision of the direct estimation. Okay, and then the last methods. We are fitting EBLUP model augmented. The function name of augmented benchmarking is EBLUP-AUG as follows. And then these are the estimation results at district level. When we aggregate at the provincial level, we meet the benchmarking properties. We also check the MSE and RSE, and using augmented benchmark, we can improve the precision, and augmented benchmark perform better than different benchmark and Euro benchmark. So we can conclude that using small area estimation benchmark, we can improve the precision of the direct estimation, and we can make sure that the estimation at the district level meet the consistency when we aggregate it into the provincial level of estimation. Okay, everybody, I think that's all our sharing about the estimating the disaggregated regional official statistics in Indonesia using EBLUP benchmark small area estimation methods using R. I hope it can be a nice insight for all of us, and thank you very much.